In 3-6, you're going to learn one more way to solve using systems, and you're going to learn how to solve today using what we call a matrix. Plural is matrices. Now, we should review that you have learned how to solve using tables. We decided that wasn't always the best. You have also learned how to solve using graphs. Again, that's okay if our numbers are whole numbers or integers. You have learned using substitution, which a lot of you really like. And you have also learned to use elimination. If you're really good at elimination, I bet that you'll think today is going to be pretty easy. All right, our objective is to be able to first represent them in a matrix, and then second, to be able to solve them. You're really going to like the first part of the lesson. The second part of the lesson, you're either going to love it or you're going to hate it. It's another way of solving. But the first thing we need to make sure you're okay with is the definitions in this section. A matrix. Just like you would think, like the movie The Matrix, all those ones and zeros and an array of numbers. Well, today, a matrix is kind of the same thing. We have a rectangular array of numbers. They're going to be in a big set of braces, okay? You're going to have a whole bunch of numbers inside of here. They'll be all lined up. They could be three rows. How many ever rows or columns? They can be pretty large. How do I think about a matrix? Like an Excel spreadsheet. Now, a matrix element is just a certain number in the matrix. It's like a single item, so like maybe that number there. Row operation is what we're going to talk about later. It's how we solve matrices. It's a way that we're going to move the rows around. Now, if you want, this Got It will help you. It's kind of like a little game to try to figure out how matrices work together. You can do that yourself if you want to kind of get a warm-up. It will help you for when we begin to solve. In problem 1, we're going to start by identifying a matrix element. So this is going to help you with your vocab. Now, if a problem asks you what an element is, this first letter represents the elements inside the matrix. This 2 and 3 does not stand for 23. The 2 stands for row number 2. The 3 stands for column number 3. So they're asking what is in row 2, column 3 of matrix A. Now matrices are always defined by capital letters. So this entire thing is A. What is in row 2, column 3? Remember that rows are horizontal, just like you would row a boat. Columns are like, columns on a house. They're up and down. So row 2 is this second row, 0, 5, 8, 6. Column 3 is this column, 17, 8, and 10. So when they ask what is A, 2, 3, the answer is 8. It's the second row down, third column over. And that's all we have to say. Alright, so that helped us with a little bit of our vocabulary. Let's try that one more time and I got it. What is in A, 1, 3 of matrix A? You ready? So go to row 1, column 3. The answer is 17. And that's all there is. Now you know what an element is and you know how to find one. In the next part of the lesson, I'm going to teach you how you can take an x and a y, two xy equations, and put them inside of a matrix. Alright, so let's say that I gave you a system of equations that had these two equations. X plus 3y equals 7 and 3x plus y equals negative 8. You put your x coefficients in the first column, you put your y coefficients in the second column, and you put what they equal in the third column. Notice that there is a thick dividing bar. I call it the great equal sign. It's because it replaces your equal sign up here. So the coefficient of x here is 1, which is why they have a 1. The coefficient of y is 3, which is why they have a 3. And it equals 7, which is why they have the 7. The same thing applies for the bottom row. In problem 2, that's all we're going to practice. We're not solving them yet, we're just practicing representing them. Alright, we are not solving yet, we will get to that. So how can you represent this system of equations in a matrix? Draw your box, draw the great equal sign. The coefficient of x's go in the first column, coefficient of y's go in the second column, what they equal go in the third column. So we write a 2, a 1, and a 9 from the first equation, xy equals, and a 1 a -6, be careful with your negatives, and a -1 in the second row, and that's it. Now that's all they want you to do. Again, these will get more difficult. Right now, we're just making sure you understand. In problem B, I first want you to realize that these need to be in order. Okay? When I say in order, they need to be x, then they need to be y, then they need to be z. Now the first equation is perfectly fine. I can give it a check mark. It's x, y, z equals. The second equation is perfectly fine. Notice there is no y, so we just do x, z equals. That one's fine. The third equation needs to be rearranged. We need to move a 5x to the other side. So 5x, because x belongs in the front, plus the y, there is no z, equals 1. Now it's okay. Now that it's okay, we can go ahead and make our matrix. This one is going to be a three rows tall, and the x's go in the front, okay? And then the y's, and then the z's, and then the equals. Let's do the first equation. I actually think it will be the easiest. Coefficient of x is 1, coefficient of y is -3, coefficient of z is 1, the great equals sign, and it equals the 6. So the first one wasn't too bad. Now the second one, the coefficient of x is 1. Now you might say, since this is x and this one's y, what's the coefficient of y? Well, since there is no y, its coefficient would essentially be 0. And the coefficient of z is 3, and it equals 12. In the last equation, remember, we're not using this one because it was out of order, so we use the coefficient of x is 5, the coefficient of y is 1, there is no z, so its coefficient would be 0, and it equals a 1 at the end. Now that's all. Again, these will get harder, but this is just practicing putting them into a matrix. Moving on to the got it. Can we do this one more time? Make sure they're in order, which both of them in A are. Put your equations in there with your great equal sign. -4, -2, and 7. 3, 1, and -5. That's all there is for that one. Remember x, y equals. And in part B, rearrange them, x, y, z. This one needs rearranged. We do 2x, bring the y over, make it plus y equals 7. Cross the old one off. Everything else is in order. This one will be 3 tall because we have 3 variables and 3 equations. 4, -1, 2, and 1 for the first equation. There is no x, so 0, 1, 5, and 20. And the last one, 2, 1, 0, and 7, because there is no z and we moved the y over. So that wasn't too bad. The next thing we're going to do is go backwards. Alright, so we're still kind of on the easy stuff right now. Problem 3 is going to give you a matrix, and it says what linear system, in other words, what equations does it represent? Remember that it goes x, y equals. Okay, so the top one is 5x plus 2y equals 7. The bottom one is no x, just 1y equals 9. That's it. Equation number 1, equation number 2. Notice when x is 0, I don't even bother to write it. The got it. So we can do 2x equals 6. Remember, there is no y term because this is 0. Then the second equation would be 5x minus 2y equals 1. Again, this is going to get harder, but for right now, as long as you understand the basics, how you can go back and forth, that's what we're getting at. As we move on, this page is where it becomes complicated. Here's your main idea, okay? You're going to start with a matrix, like that. You can flip things upside down, if that's beneficial to you. Doesn't have to, but it can be beneficial. Something else that you're allowed to do is you can take it and you can multiply any row by something. So the bottom row in this case got multiplied by 2, and your final answer became that, 4, -2, 6. So these are, what this is I call this, what are you allowed to do? Okay, I'll show you why you're going to use these in a little bit, but let's just go over what you are allowed to do. The other thing you are allowed to do is if you have a matrix, you can add the rows together. So the top row added the bottom row is this final answer, because 3 plus 4 is 7. Let's see if I can point it out. 3 plus 4 is 7. 2 and negative 2 is 0. 5 and 6 is 11. Notice the bottom row stayed the same the whole time. So these are all legal moves. You really don't have to watch this video because I'm going over it right now. Our goal is going to be, are you ready? Our goal is that we are going to start with a matrix that has numbers all over it. Okay? Those numbers could be any numbers at all. At the end, maybe kind of in the middle, we need to make sure our matrix, and I'll teach you how to do this, but we want our matrix to have a number at the top left, and then a 0, and then a number. We want a 0, a number, and a number on the bottom. In other words, these items have to be 0. Our final answer will be when we have a matrix with a 1 here, a 0 here, a 0 here, and a 1 here. Our answers will be whatever is on this side. Alright, let's play around with this and check it out.